Hello, hello, hello. Okay, so yes, I'm audible. For some reason, um, it's just some um microphone issue. I'll try to fix that. I'm sorry. Okay. Given a set of integers and then a sequence of queries, a query gives you a number and asks you to find out a sum of two distinct numbers from the set which is closest to the query number. Input contains multiple test cases, each query with an integer. This query starts with an integer n. The n ranges from 1 to 1000, which indicates how many numbers are in the set of integer. Next n lines contain n numbers. Of course, there is only one number in a single line. Why they're saying of course? I don't know why. Yeah, okay, next n lines. Okay, the next line contains a positive integer m, and the next m lines contain an integer query, one per line. Input is terminated by n equal to 0. This case needs no processing. Okay. What is the question number? 10487. UVA 10487. Yes. One thing which I would like to, talk about is let's say you have a bunch of numbers. Let's say you have a bunch of numbers. Let's say 1, 3, 5, 6, 8, 10. Let's say, and you have to, find out any two elements. You can use any two elements from the array, and the summation of these two elements should be as close to what? Should be as close to um let's say our target. Our target is let's say our target for this case is let's say 11, not 11. Let's say it is it's 8. Yeah, 8 is a 8 is a great target. And what you can do is first of all, this array should be sorted, and you can use two pointers method. You have a low pointer over here, high pointer over here. So array of al plus ah is, what is al plus ah? It is 11. Now as 11 is greater than 8, you have to find out, you have to use a smaller number, isn't it? You have to somehow decrease either of the elements, either al or ah. Now can we reduce the value? Now can we find out an element which is smaller than al? No. So what we can do is we can uh, shift this pointer h by 1. So now we will have al plus h, and now it is equal to 9. But 9 is still greater than 8. So we'll shift our pointer. We'll shift our pointer. We'll shift our pointer, or we'll decrease our pointer h. So now h will be pointing at 6 plus 1, which is equal to 7. Now 7 is smaller than 8. So in this case, we want to find a greater number. We have to increase some ah or al. Now incrementing ah doesn't make any sense because we will be, we'll be stuck in this loop forever. So instead, we'll increase l. As you can see, 5 plus 3 is still not 5 plus my bad. Yes, 3 plus 6 is equal to 9, which is greater than 8. So we have to find out a smaller element. So we'll shift our h pointer towards left, and then we'll have 5 plus 3, which is indeed equal to 8. And we can return from this. We can return from this discuss from this case, and we will continue to do so until L is not equal to H. I guess this makes sense, isn't it? And yeah. So what do we need in output? Output should be organized. Okay, closest sum in the format as in the sample. Okay. So first of all, what is needed for this technique is that the array should be sorted. Yeah, but there's no mention of that the array is sorted. So we'll first of all sort our array, and this will need big of n log n, and a we will need n iterations to completely scan through this array. And yes, so our final time complexity will be big of n log n plus n. And this test case is sufficient, I should say. This time complexity is sufficient to solve this problem. So let's get into it. Before taking any sort of input, we will first I guess let's take the same input. What is the input? 1 3 5 6 8 10. 1 3 5 6 8 10. Okay, and we have to return a number which is closest to okay. Not void. What should we call it? Closest sum. Get clo get closest sum. Okay, we'll have our array and we'll have our target. Initially low is at this high. Okay, yes. High will be at error the size -1 int answer is equals to arr z arr low plus arr high. Okay, and distance will be absolute of answer minus target. Okay, so if I low is smaller than high, yeah, And if instant sum is equals to ARR of low plus ARR of high. Okay. First of all, we'll check if distance is greater than absolute of instant sum minus target. If it is, then yeah, and distance is equals to absolute of instant sum minus target. We'll check if instant sum. Okay, let's say if it is equal to target, we'll simply return target. If instant sum is greater than target, then the radius high, else the increase low. And at the end, we need to return the answer. Let's call this function. Here get closest sum ARR and the target is 8. 10487 8. Okay, let's say our target is 9, so it should either return. Okay, let's see the closest sum in the format is in the sample. Okay, so can we get 9? Okay, we can get 6 plus 1, 9. Can we get 10? I guess 9 is the clue. Okay, 11. Fair enough. Um, we can get 11 itself. Can we get 2? I guess the answer will be 4. Yeah, 3 plus 1. Can we get 6? We can indeed get 6 somehow. Okay, 5 plus 1, 6. Okay, great. So what now we are? So what's our job? We need to first input the test case. Each contest. Okay, well true. And n will take the input of n. If n is equals to 0, then we'll simply break. If not, we'll take the input of the array. We'll take the input of array. Then we'll have integer m, and we'll have a test case. Int query, in query, and then we'll simply pass the query. And finally, I guess we should. Okay, we need a bit of a formatting. Cout. Okay, closest sum to query is get closest sum ARR query Then we need a new line. We also need to maintain a case number. Our output should always start with case, case number. Yes, we don't need an extra new line. Okay, so let's check UVA14 closes sum to 1 is 15, closes sum to 41 is 51, closes sum to 30 is 29, closes sum to 1 is 3, closes sum to 2 is 3, closes sum to 3 is 3, closes sum to 4 is 4, closes sum to 5 is 5, closes sum to 6 is 5. Then we'll submit our answer. Okay, and yeah, we got a wrong answer. Okay, so something shall be wrong. Okay, what's wrong over here? We are always decreasing high and increasing low. Okay, in case if we have made any silly mistake. But there's the thing, okay, there's the thing, because there can be two answers. Let's say the closest sum to 10 can be 9 and 11 as well. I guess by just, okay, let's just add an equal to sign over here, because get closest sum which is smaller than, I guess, okay, just let me try this. I don't think our solution is, what can I say, wrong or something. We did the wrong answer again. We didn't get any presentation error as well. Case one. Okay, I guess we forgot. Yeah, forgot a full stop. Hopefully now we'll get our answer. Okay. Hmm. What's wrong over here? I don't understand what's wrong. No, airport will. Line 12. Um, my bad. We have an extra new line. Is this new line causing an issue? I guess so. One zero four eight. Okay, and now I guess it was a presentation error. Okay, no, it's not a presentation error then. Are there any chances of overflow? Um, okay, so let's ask ChatGPT. Oh no, man. They're thinking the radiation, but there's a critical flaw. Let's not jump immediately to fix. Okay. What assumption does this technique make about array? Oh my god, we haven't sorted the array yet. Oh my god, yeah. Uh, algorithm. Yeah, we haven't actually sorted the array. My bad, guys. Yeah. Sorry, guys. Guys, so I guess in the notes while we were discussing this, we had indeed written that the array should be sorted. But, okay, wrong answer again. This is interesting. Okay, let's. How is this impossible? We compute all possible pair sums. Not fantastic. How come the two pointer? Check all possible pairs. You don't have to check all possible pairs. That's what I aiming for, isn't it? That's why big often. That's why I'm trying to solve it in big often because I want to write a better algorithm rather than using the n square algorithm. I need to understand why my two pointer strategy fails. What's wrong in two pointer? Counter example. Before queries, I have done. I have already sorted the array as well. Then what's the issue? There shouldn't be any issue. Should be. Should there be? I don't think so. Moving by the greedily won't skip the optimal pair, but that is not guaranteed. How is it? How is it so? I would really like to find out a test case where Um, Almost career very close. This that is close. Almost career, but certainly wrong. Theoretically, what I have written is valid because the thing which I'm worrying about is that there can be there can be two best distances. And in that condition, I don't know if the judge is actually assessing the difference. Something's messed up. Something's messed up with this question. Something's wrong. Something's inherently wrong in either the theory which I'm thinking of. Because to be honest, I can't find a flaw uh, in the logic which we have discussed. Yeah, I can't find a flaw because how will it skip any of the optimal pair? We are indeed actually approaching the optimal pair, and I guess we can also check this out on the two sim question. Which I guess it is the first question of lead code. It is solved using the exact same logic. I got it all answer. Okay. I still don't realize what's wrong here. You know what? Well, first of all, mark this as yellow and will write a comment. Not working to enter approach. We'll add this. Yeah, and we'll quickly move on with the next question. I guess we'll end the stream after solving these four questions, and after that, in the next stream, we'll be continuing with divide and conquer paradigm 10730. Okay, anti-arithmetic. A permutation of n is a bijective function of initial and natural numbers 0 to n minus 1. A permutation P is called anti-arithmetic if there is no subsequence of it forming an arithmetic progression. Subsequence, okay, of length bigger than 2. Okay. There are no three indices that form an arithmetic progression. Okay, for example, is an anti-arithmetic permutation of 5. Okay, the sequence is not an anti-arithmetic because first 15. Okay, 0 and 2. Okay, they have a difference of 1, and so do its second 5 3 1. Okay, interesting. Yeah, your task is to check whether given permutation n is anti-arithmetic. Okay. Okay, n is 10,000. Let's just, you know, think over the fact that n is 10,000. So I want to ask you a simple question. What? Okay, so first of all, let me say that d is the difference between between two terms of AP. Okay, so what can be the maximum value of? We'll try to max val of d. I guess max value of d will be n by 3. Let's say if we sort, we can have these three elements. Let's say we have 6 over here, we have 0 over here, and then we'll have 3 over here. Not n by 3, I guess n by 2. So first of all, we'll have a will be equal to 0, and a plus n minus 1 d, n minus 1 is 2, 2 minus 1 d, d should be smaller than equal to a plus n minus 1 d. This should be equal to 6. A 0 plus n here in this case is 2, 2 minus 1 d, d is equals to 6. How can d be equal to 6? No, this is 3. Okay, my bad. Here should be 2. So 2d is equals to 6 and d is equals to 6 by 2, which is equal to 3. Okay, so the maximum value of d is n by 2. It can be plus, it can be minus. Okay, find the subsequence. Now what is the meaning of subsequence? We can take any of the any of the three elements from an array, but they should be in the order in which they are present in the array itself. Let's say we can't pick 063. We have to pick it in a we have to pick these elements as per their order in the array. I guess if that makes sense. So what I can do is, as we know that d can range from minus n by 2 to plus n by 2. Okay, so yeah, so the iterations required for, let's say I have an element at index I, and I have to find out, and I have to check for all these d's if there's any arithmetic progression. So n iterations are required, and I have to iterate through the complete array from 1 to n. So the complete um time complexity will be big of n square, but you have to use some text. Let's say now you may ask, how will I understand if, let's say, 6 is indeed present to the right of 3? First of all, we'll check if let's say a plus d is in the range. We'll in the range, and we will keep a digits straight. Uh, oh, I can't, I guess, because there are 10,000 numbers. Can't use digits. I guess or even I can simply use a vector bool and mark it as present as I'm iterating through the array, and we'll check if it is false and so on. So yeah, okay. Our next question is 10730 anti-arithmetic. I will close everything. Why did I do this? Okay. 10730 UVA 10730.cpp. Yes. And I guess before writing any of this, we'll just write our answer. Bool has AP, will have a vector int ARR, will have vector bool state, we will have a integer id, and yeah, so we have to iterate d from negative n by 2. Here n is ARR dot size by 2 until d is smaller than equal to ARR dot size by 2 d plus plus d plus plus, and yes, we have to check. Okay, int a1 will be equal to ARR of I and d plus 0 into d. Int a2 will be equal to ARR of I and d plus 1 into d. Int a3 equal to ARR of I and d plus 2 into d. Bool is in array. We will state and int num. Okay, if num is smaller than 0, or num is greater than equal to n, okay, state dot size, okay, will directly return false. Else if we will return yeah, if we will check is in array for a1, we'll do the same for a3, a2. If yeah, then we'll return true. If not, then we'll move on, and at the end we'll return false. Let's say ARR is 0, 1, 2, 3. cout as AP for ARR, and let's say vegetable state. Let's say 0, 0, 0, 0. We haven't included anything as of now yet. Okay, if it is marked as present, present means visited. Yeah, okay, and it's not visited yet. So what's the first thing we should do is set IND should be marked as true. If d is equals to 0, we don't have to do anything, we'll just simply continue. Yes, cout as EP ARR state, and let's say IND is 0. We should get 1 for this. Okay, so 4 by 2. Okay, 4 by 2 is 2, so D should change from -2 to 2. Talking about a given number, okay, one thing we can do is, but 3 isn't, okay, something's wrong. Okay, we'll have a, we'll print D, and then we'll print A1, A2, A3. What is going on actually? Not AR or IND. Why are we not even printing? Something's wrong. Okay, hello. Okay, what is happening once we, okay, 4 divided by 2. For some reason, let's say, are we making yet another silly mistake? Hello. Okay. What is going on? I'm actually worried. What is going on? What is this? What? I don't get it. What is ARR? 5 is 4. So ARR says it should be 2. Okay, I guess we have to multiply it by. And next D. Well, first of all, 2. Okay, I guess guys, first thing, I really don't know what's going on over here. I guess we'll. Yeah, still didn't get A1. Pause D. Okay, so for -2. Okay, okay, for 0, 0, 0. And for 1, 0, 1, 2. We should mark it true at the end, I guess. Now we'll get 1. Okay, fantastic. One thing which we can add is if d is equals to 0, there's no point. Just continue with with your life. Okay, we will remove this weird hello. And yeah, I guess now we are good to go. Okay, so for E we have to do this for each IND. Not for each, I guess we can skip the last two indices. Okay, and at the end, bool get answer will have a vector ARR, and what we have to do is I runs from okay has a B and will have vector bool will make it over here. Vector bool state that size age will be false. Error state and int if it indeed has an AP will return and at the end will return false if it didn't find an AP. While true as usual int and scene and if break char colon cin colon and then we'll create an array of size and we'll take the input. After taking all of these inputs, we will print get answer ARR. If it is true, we'll print yes. If it is not, then we'll print no. Yeah, fantastic. We have an yes. If true represents that we have already visited, I guess we will focus only on this case. Yeah, okay. We'll not print new, then we'll just for zero itself, okay. And for zero, okay. I guess I have messed up. I guess I have messed up. Yeah, I messed up big time because I'm not considering. Oh shit, man. Shit. I'm not. Oh shit. This is annoying because. Yeah, fantastic. We will have another kind of state. Yeah. Okay, now what we have to do is we'll first of all assign -1 to each of these, and then okay, if okay, we'll assign, we'll have mapped value, we'll have the elements mapped with the indices. Okay, and at the end what we can do is if and ind1 equal to is an array state a1, we'll do the same for a2, a3, and we'll have ind2, ind3 if ind1 is equals to -1, or simply continue. If not, then if ind1 is smaller than ind2 and then ind2 is smaller than ind3, return true. We do have an AP, don't we? Am I bugging, or we do have an AP and subsequence? Sub- Subsequence in, yeah, C++. Contagious part, okay. A subsequence is a sequence that can be derived from any sequence by removing zero or more elements of the change in the. Okay. Okay, we're not that stupid, aren't we? I can clearly see. Okay, my bad. Anti-arithmetic, not arithmetic. Okay. And I guess we'll. Yes, no, yes. Okay, yes. I guess. Okay, I guess this solution is enough. I guess I'm getting an WA for this. Okay, accepted. Okay, fantastic. Fantastic. I was not that confident. I thought I have missed something. Okay. First of all, this solution code is. We'll check if there is any other method using which we can solve this problem. The question is, yeah, it's a good attempt here. Later logic goes wrong. I guess sometimes ChatGPT just waffles some garbage. Nah, 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 nah. Nah, nah, nah. I guess we're good. Nah, nah, nah. This is pretty much a good solution. Actually, big offense score and everything. Sometimes ChatGPT I guess hallucinates, and we haven't yet gotten AC, so we don't have to worry about it. 11242. 11242. Tour de France. I was actually checking this website because I thought that um I misinterpreted the meaning of the question. I thought the question is talking about subarray and not subsequence, but um we were right. We were right all along. Okay, and we have three more questions to go. Okay, so yes. 11242 Tour de France. Okay, a racing bicycle is driven by a chain connecting two SP rockets. SP rockets are grouped into two clusters. Different cluster typically consisting of two or more SP rockets, and the rear cluster typically consisting of between 5 and 10 SP rockets. At any time, the chain connects one of the SP rockets to one of the rear SP rockets. The drive ratio, the ratio of the angular velocity of the pedals to that of the wheels is the quotient n upon m, where n is the number of teeth on the rear SP rocket and m is the number of teeth in the front SP rocket. Two drive ratios d1 is smaller than d2 are adjacent if there is no other drive ratio d1 smaller than d3 and d3 smaller than d2. The spread between a pair of drive ratio d1 upon d2 is their quotient d2 upon d1. You have to compute the maximum spread between two adjacent drive ratios achieved by a particular pair of a pair of front and rear clusters. Front and rear clusters. Okay. The number of spirochetes in the front cluster, the number of spirochetes in the rear cluster of integers each giving the number of number of teeth in one of the gears in the front cluster are each giving the number of teeth on one of the gears in the rear cluster. You may assume that no cluster has more than 10 spirochetes. Okay, two drive ratios are adjacent. Okay, you compare the maximum spread. Okay, so to be honest, I haven't understood the question yet. Let's try to understand. Okay, so there. Okay, so this two is number of sprockets in the front cluster and four is the number of sprockets in the rear cluster. Okay, number of teeth. 40, 50, and we have 12, 14, 16, and 19. Okay. What is the drive ratio? The ratio of the angular velocity of the two pedals wheels is the quotient of n upon m. Okay. Okay, first of all, we'll tag them. Okay, front cluster, and this is a rear cluster. Okay. Ultra teeth. Okay. And is the number of teeth on the rear. Okay, rear Okay. Do you have to calculate each and every D1, D2 and everything? Okay, this is quite interesting then. Then what? Okay, first of all, we'll calculate D1 is equal to 40 upon 12. Okay, so we'll bring our calculator. Okay, so as of now, we will have 40 divided by 12. Yeah, 3.33. D2 will be 40 divided by 12. What? 40 not. Okay, 40 divided by 14. 2.857. D3 will be 40 divided by 16. 2.5. And D4 will be 40 divided by 19, which is 2.105. 2.105. This is one group. D5 will be 50 divided by 12. And sorry for the delay. And D5 will be equal to 50 divided by 12. 4.1667. D6 will be equal to, I know this may feel tedious, but after uh, dry running at least one problem, the overall question feels pretty easier. D7 will be 50, 50, 50 divided by 16, which is 3.125, and D8 will be 50 divided by 19, 2.6315. Okay, now I understood that. Okay, maximum spread. Okay, okay, we have to find um spreads. Okay, so let us go through our journal. So we have to, I guess we have to first sort the array. So the array will look somewhat like 4.1667. Then then 3.571. Then 3.33. Then 3.125. Then 2.85857. 2.6315. Then we'll have 2.5. 2.5. We will have 2.105. And what is the meaning? Okay, so the meaning of the quotient of d2 upon d1. Okay, so we have to find out d2 upon d1 such that there is no d3 in between them. So we have to find out um the edge. We have to find out, let's say, the division of all these numbers, and then we have to return the maximum. So yeah, the question is pretty neat and clean. And why will this work? Will we get TLE? Answer is most probably not, because the constraints are too small. Um, you may assume that no cluster has more than 10 SP rockets. Okay, so each cluster, okay, let's say there can be 10 comma 10 clusters, and each can have 100 teeth, 100 comma 100. So the maximum number of iterations required is actually 10 to the power 4, and for sorting we will require a log n time complexity. And yes, I guess this will suffice. So the question is actually pretty easy, but uh, usually in ICPC type contests, the wording makes it sound so difficult. So yeah, question number is 112242. UVA 11242. CP. While true, first of all we will take input of F and R. Int front cluster comma rear cluster. I know that these names are too lengthy, but personally it adds clarity. That's why I send them so lengthy names. If front cluster is equals to 0, if not, then we will take the input for rear cluster, and then we will have vector front teeth. Yeah, we will have integer data type for this array, and then we'll have front cluster. This is take the input for front cluster I plus plus. Scene front teeth. I will do the same for rear cluster and rear teeth. Okay, after taking the input rear teeth, then we will have a double. You know what? We'll assign these as double as well. We'll have double, and yeah, and yes, drive ratios. Drive ratios dot reserve front cluster plus rear cluster. Yeah, then we'll calculate front cluster and instant f front teach I and instant rear teeth. Oh, okay, so and instant R is given. Now double, yeah, double instant R, double ratio is equals to instant F, instant R. Okay, drive ratios that push back ratio. Then we'll sort. Okay, and yes, double answer is 0. Okay, so double instant answer will be drive ratio of I minus 1 divided by drive ratio of I, and then we will assign answer to maximum of answer comma instant answer, and then we will print answer. If our understanding is correct, then hopefully we'll get 1.19. Yeah, we have to look into the two decimal places thing. First, guys. Okay, so we have taken input for front cluster. Then we have taken input for rear cluster. Okay. Yeah. 0.95. That's concerning. Let's first print our drive ratios. Oh, my bad, my bad. Okay, I just didn't clock. I'm actually that's size -1 and I is greater than equal to 0. Yeah, mistakes happen. Yeah. Not I plus plus I minus minus. 1.875. Okay. And I guess we need uh an inbuilt. Okay, so I guess we need an inbuilt library to print only two decimal places. Okay. How do I print two decimal places in C++? Okay, so double round to and precision. Yes, I don't understand what this function does, but let's see. I thought there would be a double precision. Return round of value upon precision. Let's check. That include I guess C math. Mm, round to value the answer, and we need. Whoa, 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 whoa. Precision. Why am I getting two? This is annoying. To be honest, I was thinking in hindsight, something this. Okay, let's check floor in C++. Okay, in math library, a floor calculates the largest integer that is less than or equal to a given floating point number. Okay, okay, and what is okay? Okay, so I guess we have to write a consume function for this. So what we can do is let's say our answer is 1.875. We'll write it a bit neatly 1.1.875. So what we wish to um 1.1875. Okay, yeah, 1.1875. So what we can do is we can multiply it by 100. So we'll have 108.75, and we have to check if this is we have to check if this part. Sorry, I have to somehow check. Oh my God, what am I doing? Okay, I have to somehow check if this part is greater than 50. I guess there shall be a IMNF function, I guess. Let's just check. Yeah, printf, point 3. Yeah, oh my God. Oh my goodness. Why am I doing, why am I, doing so many things if I have a built-in function which allows me to point to f slash n and this is the answer. Yeah, and this does our job pretty neatly and cleanly. Let's just submit this question. And hope we get an AC. You know what? Sometimes your fundamentals should be so strong that you shouldn't forget about um, these small tricks. These small tricks, like you can print using printf only two or let's say n n decimal places of a given double number. You know what I mean? Yeah. Let's start with our next question. It is start grid. Start grid 12488. 12488. Okay. And Logonia. Okay. This place is pretty famous in. Okay, this place is pretty famous in this UAV, in these UVA problems. Okay, and Logonia will hold the sensational world final of the Formula 17 Drivers' Championship. Competitors line up at the start and compete for the race. You will have the access to the start and finish grids. The question is to determine the minimum number of overtakes that were made during the competition. I guess I have solved some similar problem. Okay. The input contains several test cases. Each test case uses three lines. The first line of a test case contains an integer n indicating the number of competitors. Each competitor is identified by number from 1 to n. The second line contains the n competitors in order of the starting grade. The third line, yeah, fantastic. The third line, okay, the third line of each case has the same competitors, but now in the order they finish the race. Okay. For each test case, print a line containing a single integer, the minimum number of overtakes. We have to emphasize on the number minimum because in usual Formula One competitions there can be multiple overtakes. Let's say Mercedes versus Ferrari. Initially, Ferrari is in front of Mercedes, then Mercedes overtakes, and Ferrari overtakes, and this goes on for a couple of times. But yeah, we don't have to worry about this. And this question, if Mercedes is in front of Ferrari in the starting grid, then at the end, um, if Mercedes is still in front of Ferrari, then there is zero number of overtakes, minimum number of overtakes necessary. Ah, Let's take this test case. 1, 2, 3, 4, 5. And it's and it's still 24 itself. Fantastic. 3, 1, 2, 5, 4. So as you can see, 5 has overtaken 4 only. 3 has overtaken 1 and 2. 2 hasn't overtaken anyone, and 1 hasn't overtaken anyone. So 5 has overtaken 4. Okay, so 1. 4 hasn't overtaken anyone. 3 has overtaken 2 candidates, and they haven't overtaken any of the competitors as well. So the answer will be 3. Let's check the second test case. 3, 1, 2, 5, 4. 1, 2, 3, 4, 5. So 4 has overtaken 5. 5 hasn't overtaken anyone. 2 hasn't overtaken. Okay, sorry. 5 hasn't overtaken anyone. Okay. 2 has been over. 2 has overtaken 3. 1 has overtaken. Has it overtaken anyone? Yeah. And 3 hasn't overtaken anyone. So the answer shall be 2. Just 3. How come 3, 1, 2, 5, 4? 1, 2, 3, 4, 5. 4 has overtaken 5. 5 hasn't overtaken anyone. 2 has overtaken. And 1 has overtaken 3. 1 has overtaken 3. My goodness. My God. Okay, 1 has overtaken 3. Yeah. Let's talk about the test. Let's talk about the test case. 3, 1, 2, 5, 4, 5, 3, 2, 1, 4. 5, 3, 2, 1, 4. 4 hasn't overtaken anyone. 4 hasn't overtaken anyone. 5 hasn't. 5 has overtaken 2 and 3. 2 hasn't. 2 has overtaken 1. 1 hasn't overtaken. What didn't overtake anyone? Answer should be 4. Okay. So we have to somehow find out. Let's say I'm talking about 5. I have to somehow find out, and the very constraints are very minimal, I guess, because you can implement a big of n raised to the power 4 algorithm, and you'll be completely fine with that. So we have to write a function such that, let's say, talking about 5. There are certain elements which are to the left of 5, and at the end we have to find out if these elements are now on the right hand side. Okay, so first of all, we'll start. I don't know how to actually write this function. Let's think about something. Let's say I'm standing at 5, so I will check. Okay, first of all, I will have four arrays. Four arrays. The first two arrays are these arrays itself, and the second array and the third and fourth array will be the mapping. Let's say 5 is at index 3. 5 is at index 5 0 1 2 3. 5 is at index 3. 4 is at index 4. 2 is at index 2. 1 is at all of this. And I will have the same thing for the ending grid as well. And then let's say I'm at 5, so I will uh go through each and every element. No, I will have only three arrays. So let's say I'm at 5, so I will uh check all the elements which were in front of 5, or I can say which have an index smaller than the index of 5 and starting grid, and we'll check if the index is greater than 5, um greater than 5 in the ending grid. If yes, then we'll increment our answer. If not, then we won't increase our answer. One of the nine mistakes which a person can do is that I guess, let's say 5 has gone up. Yeah, I guess we can do that as well. 5 has gone up by 3 ranks. So 3 has fallen by 1 rank. 2, 1 has fallen by 2 ranks. 0, 2 hasn't fallen in. No, no, no. I guess we can't do anything like that. So yeah, let's just implement what we have just discussed. And yeah, okay. So the question number is 12488. Hmm, Okay, there are no number of test cases. Fine. Actually, this is a big of n solution, isn't it? Okay, while true, we won't do this is int while c in n. Then we will have int starting grid vec- vector int starting grid n. Vector int ending grid, and then we will have vector int car to rank. Yeah, car to rank will have these, and as well will I plus plus car to rank. Okay, so ending grid of I, let's say 5, represents a rank 0. Yeah, and then let's go for int I equal to 1, I smaller than n, I plus plus. For int j equal to 0, j smaller than I, j plus plus. If car to rank of starting grid of j is greater than I on set plus plus, and then we'll print our answer. Okay, so okay, yes, it has one best indexing. How do I handle these one best indexing? Shall I just simply okay, this is not a good practice though. Okay, I won't do this. Actually, I was going to decrement the car tags by one in the input itself, but usually this is not a good practice as we are manipulating the input. Okay. We'll just simply decrease these over here, and I guess we'll be good to go. 011. Okay, that's a stinker. We'll just okay. So car to rank. Let's just print car to rank. Okay, so one car one is it rank one meaning two. Car two is it rank two. Car three is it rank zero. Car four is it rank four. Car five is it rank okay. So I guess we are good to go. Let's say I am at index one. The zero if one is at index one. Okay. Okay, let's just make a few changes. 334. Okay, fantastic. Yeah. I guess now we are good to go again. So basically, what I'm doing is I will let's say I'm at this index, so I will check the cars rank, all the ranks of the cars which are on the left hand side, which are in front of this car initially, and we'll compare the ranks of this car and the remaining cars. If this car is by chance in front of any of the cars which were initially in front of this car, this meaning the car at index I and D, then I will just then I'll just increase the answer accordingly. Let's just submit. Okay, we got an AC. Fantastic. Simulate overtaking process. Yes. 1253. Uh, the last problem of today's stream. 12583. Memory overflow. Okay. Okay, this is indeed a lengthy question to read. Memory overflow. The great Sultan Mahbub is having some serious issues with his memory. His busy days, filled with great works and surrounded by even greater people, have brought him to a situation where he has become quite forgetful. For example, he often forgets trivial things like the size of his suit, his weight, small grammatical issues related to gender and number, the address of his in-laws house, how to ride a cycle, deadlines, the day of the week, the name of the guy who forgot his wedding day, and even the date of his own wedding. Okay, they're spending the day writing alternate solutions to writing alternate solutions to ICBC problems. But when his father-in-law captured him to his in-laws' house and he failed to recognize his mother-in-law, it became a fiasco. Fantastic. And after after some rather presumable events following the debacle, the detail of which does not seem really safe to mention, he decided that the matter has become pressing enough for his attention. His position is startled by this real problem and decides to collect statistical data to begin with. During the examination period, consisting of n consecutive days, the Sultan meets a single person every day. He only recognizes the person if he has met him in the last 3 days, excluding today, of course. You need to count the number of days. Among these n days, he manages to recognize the people the people he meets. You can assume that before these n consecutive days, he did not meet any person. Input. The input contains. Wow, wow, wow. Okay, input. The input begins with number t, the number of test cases. Each of the following contains a case. A case begins with n. N belongs to n is in the range of 1 to 500, and k is in the range of 1 to 500 as well. A list of n names follow. All names consist of a single uppercase letter, and names are unique. Okay. They are given a. Okay, okay, gotcha. Okay, they are given an order of which Sultan meets them during the investigation. There won't be any invalid or space between any two names. Okay. So let's okay. I guess we will try run this in the last K days. Okay, fantastic. Let's talk about the test case. 6 to Sultan. Okay. Okay. So has he met S previously? No. So he won't recognize S. Has he met you previously? No. Has he met L? Has he met L previously? No. Has he met T previously? No. Has he met A previously? No. Has he met N previously? No. Unfortunately, our king won't remember any of the test case. Let's talk about Mahaboob. One. Maha Mahaboob. Okay. Has he met M recently? No. Has he met A recently? No. Has he met H recently? No. Has he met B recently? No. Has he met U recently? No. Has he met B? Okay, he has met B recently, but K is equal to 1, so he will only recognize you. And let's talk about 2. 6 comma 2. The same Mahaboob. Basically, he won't recognize these, and this. But during the last case, he has met B 2 days prior. So yes, he will recognize B. Yeah, so this is a pretty straightforward question. 1253. UVA 12583, and yes, CB. Okay, so we indeed have okay, they have given us a test case and CNT while T minus minus. Okay, we have to print the case number as well. Case number plus plus. Okay, have to take input n comma k. See n comma k, and I will take the string of input s. Okay, and then and get answer. Okay, and string s and int k. Okay, bool remembers does okay remembers. We'll have string s. We will have int ind ind is the person he has met. We have to return if Mr. Andy is present in the previous key characters. And I equal to no I plus plus if ind minus I is smaller than 0, then simply break if s of ind minus I is indeed equal to s of ind, Return true. He does remember. If not, then he doesn't remember. We'll have to do the same for each and every. We can directly. No, we have to start at IND0. Let's start at IND1, but you know what? Let's just relax a bit. And answer. Okay, remember. If it does remember, yeah, then good. Return answer. Case, case number. Get answer. We'll have S and we'll have K, and then we'll print a new line. Whoa, whoa, whoa. Okay. Hmm. UVA12583, and yes, zero in each and every case. I guess our remembers function is wrong. This string is S is Mahaboob and int K is 1. Remembers S, let's say M 0, 1, 2, 3, 4, 5. K is 1. 0, let's say K is equal to 0, 1, 2, 3, 4, 5. B is okay. Yeah, and minus I, not K is still equal to 1. Okay, then I guess we'll get a 1. Okay, fantastic. And now I guess we're good to go. We will try to, reduce the mistakes which we always do, and we will try to be better. 0, 0, 1. Okay, it is indeed 0, 0, 1. Let's just submit this question. Let's hope we'll get an AC. Yeah, fantastic. So from the next stream, let's just take a look at the things which we did today. Okay, so we solved the question sales. It was family, closest sums. Closest sum is a kind of sketchy going on, and closest sum I will look into this. Uh, yeah, um I guess our approach is good enough to solve this question. Yeah, and we will have and we did solve anti-arithmetic can be solved. Okay, two nested loops with pruning can possibly pass the weaker test cases. Note that with brute force, solution is too slow for for the large data set generated in the solution of UVA. Okay, okay, yeah, Tour de France. Okay, so yes, we have solved these many questions. We won't be solving. I tried you three or more nested loops, easier and harder. Uh, if necessary, we will solve them. But as of now, I don't feel that these are necessary enough. We will not be doing DP as of now. And so yes, in the evening, we will be starting with divide and conquer. I guess divide and conquer is not divide and conquer is not that relevant, I guess, in neat code. Let's check how many problems are there of divide and conquer. Okay, so as of now, I can see that um set trees heap. Okay, so as of now, I cannot see any divide and conquer solution. Yeah, divide and conquer. What can we say? It's a category, but I think that it is pretty important. I've seen okay various sorting algorithms. Okay, we'll be doing divide and conquer. Uh, we'll try to understand this bisection method. This will be the first time I'm reading all this theory. Until now, all the problems which I have solved on stream were actually solved by me in, I guess, at least in the past 1 year. So this was kind of warm up for us. And yes, I guess divide and conquer. With this section, we will start our real progress, which will indeed help us in our code forces journey as well as in this ICBC journey. You know, there's a difference between code forces and ICBC. And there's a difference between code forces and ICBC. Code forces is like code forces doesn't have such lengthy problems, but in case of ICBC, there are so much lengthy problems, and we have to think in a strategy and first target the ad hoc problems. Yeah, uh, there are complete different nuances in both of these things in core forces contest and in ICBC contest, and we'll try to maintain a balance of understanding for both of these types of contests. And yes, overall, our end goal is to cultivate a habit of solving these problems daily and become a better CPR or competitive programmer. And yes, this is the purpose of the stream. Even if you don't watch the stream, uh, don't even you have put me on mute or something. The end goal of the stream is not only learning about um ICPC or not learning about the core forces, not or not learning about CS or not learning about math. The end goal is cultivating the habit of you know becoming consistent in our things and becoming consistent in our professional life as well as in our academical life. And I hope that one day there will be thousands and thousands of people joining in with this journey. And yes, yeah, thank you very much.